All right, the other problem I wanted to talk about was number 17, which is k to the 6th minus 16. Now we're talking about the difference of two squares. So we're going to take the square root of k to the 6th and the square root of 16. And remember, if it's something squared minus something squared, then it's the difference of two squares. It can be factored. Now you might be thinking with k to the 6th, oh, well, 6 is not a perfect square, so therefore it can't be factored. However, as exponents, whenever you have an even exponent, it actually can be factored. Now remember, what we're thinking when you have k to the 6th is what times what, the same thing gives you k to the 6th. Well, if you remember from chapter 7, k to the 3rd times k to the 3rd is k to the 6th, or we can write it as k to the 3rd squared. And power to a power, we multiply. So whenever you have an even exponent, it ends up being a perfect square. So, for instance, if you had like the square root of x to the 10th, well, half of x to the 10th is x to the 5th. X to the 5th times x to the 5th is x to the 10th. So the square root of x to the 5th is x to the 10th. The square root is x to the 5th. If you had the square root of y to the 36, for instance. Well, half of 36 is 18. So the square root of y to the 36 is 18. Y to the 18th times y to the 18th is y to the 36. If you had the square root of x to the 100th, now you're thinking, oh yeah, 10. No. Remember, what times what gives 100? That's x to the 50th. So as an exponent, if it's an even, all you're going to do is chop it in half. As a number, it's different, okay? But as an exponent, it's even. So no matter what even it is, half of it is its perfect square. Odds, we'll talk about when we get to radicals. Odds will have to take the square root of it, and then we'll take the highest even power, and it's always going to have one left over. But we'll deal with that as radicals. But for right now, as we're factoring, know that whenever it's an even exponent, okay, all you're going to do is chop it in half for the perfect square root, okay? All right. The other problems that I wanted to talk to you about is the next ones, examples with a GCF. So notice these ones say here, look for a GCF first, and then factor the remaining difference of two squares. Okay, so with all of these, we're going to have to factor out a GCF first that we're left with. Okay, all right, so looking at number 21 here you have 2n squared minus 72. So between 2 and 72, notice that they're not perfect squares. So if we're just looking for the difference, we can't do that. But we're always going to try, and when we factor, it's always we're pulling out anything that we can in order to factor these polynomials. So first we're going to pull out a 2. If I can take both sides, divide both terms by 2, that would look like this. So I'm going to pull out a 2 from both of them. I'm left with n squared, and then if I take a 2 from 72, I'm left with 36. That's factoring by the GCF. That's the first kind of factoring that we did. Now we're going to factor this as a difference of two squares. So the square root of n squared is n, square root of 36 is 6, and if there's a minus sign in between, that's the difference of two squares. So what that will factor into is n minus 6 times n plus 6, or remember you can write it as n plus 6 times n minus 6. But make sure we always bring down that 2, because we took that out and that's part of the problem. That becomes your final answer. Take out the GCF, and then we're left with the difference of two squares. Another one that I wanted to do with you is like number 36 here, and I'm going to do this on the left side. So here you have 100 b to the 3rd minus 36b, okay? All right, so between 100 and 36, I can pull out a 4, okay, between my numbers. And just looking at my numbers, I would be left with then 25 and 36. 4 from 36 leaves me with, I'll have a brain fart here. Oh my goodness, 4 from 36. Oh, is 9. Okay. Yes, Mrs. Feely, I'm a math teacher. Haha. All right. The other thing that we can pull out, and I'm going to bring down my minus sign here. The other thing that you can pull out is, notice you have 3 b's here and 1 b here. So between the b's, you can also pull out one of them. They both have at least 1. So if I take a 1 from the 3, then here I'm left with 2. And if I take a 1 from this b, I'm just left with that 9. Okay, so after I pull out the GCF, my GCF, and I'm just going to rewrite it a little neater here, is 4b, and then I'm left with 25b squared minus 9. Now remember, the cool thing with the factoring is that if you pull them out, if you multiply using FOIL and the destroyer property, you end up getting the same thing as your check. All right, so now we took out the GCF, which is 4b. Now I'm looking to factor the difference of 2 squares. So the square root of 25b squared is 5b. Square root of 9 is 3, and it's a minus. That is the difference of 2 squares. So what it will factor into is 5b plus 3, times 5b minus 3. So it's 4b times 5b plus 3 times 5b minus 3. All right, so you're going to do the rest of the sheet for some examples, and I'll tell you on the Google form what that's going to be.